I'm the professor. So I hope you have been following the videos on divisibility rule of 2 and 5. So today we are going to discuss the divisibility rule for 3 and 9. So just keep in mind that these rules are only valid, only applicable for 3 and 9 and not powers of 3. So for divisibility rule of 3 and 9, or in other words we can say remainder when divided by 3 or 9, what we need to do is we sum the digits, and that sum of the digits is then divided by 3 or 9, and it is checked whether it is divisible or not. You must know that already, so I'll just write it quickly. Sum of digits is divided by 3, and for 9 we have sum of digits divided by 9. So that's the very easiest definition available for 3 and 9. So we'll quickly do 4-5 quick examples so that you can infer it much better. So we can just add the digits and then we'll check whether it is divisible by 3 or 9 and whether it leaves any remainder or not. So 6 plus 7, 13, 13 plus 5, 18, 18 plus 1, 19, 19, 3, 21, 21, 9, 30, 38 and 40. So just quickly I'll just recheck it. 13, 18, 19, 22, 31, 41. I'm sorry, it's 41. So the sum is 41. So when 41 is divided by 3, the remainder is 2. So it is not divisible. Again, if it is not divisible by 3, that means it is not divisible by 9. That is very obvious. So it is not divisible. Let's check what is the remainder here. The remainder would be 5, and it is not divisible. Now we'll come to this question. 8 to 10, 10 to 12, 12, 16, 17, 24, 24 and 10, 34, 39. So the sum we have is 39. 39 is definitely divisible by 3. 13 3s is 39. So it is divisible. I'll just write divisible here so that there is no confusion. The remainder here is 0. However, 39 is not divisible by 9. So the remainder over here would come out to be 3. And it would not be divisible. So that means a number can be divisible by 3 but not by 9. Coming to the next example, 6 to 8, 8, 7, 15, 24. Sorry, just give me a moment. 15, 24, 30, 31, 35. So the sum is 35. So it is not divisible by 3. The remainder would come out to be 2. Not divisible, and the remainder here would come out to be 7, not divisible. Coming to the next example, we have 2 plus 8 10, 10 plus 3 13, plus 4 17, plus 2 19, plus 5 24, plus 7 31. The sum is 31. Remainder here is 1, not divisible. Sorry, divided by 9, the remainder is 4. It is again not divisible. Now coming to this question, I'm really sorry, the remainder is 8 over here. Okay. Coming to this question, we have 3 plus 4 7, plus 3 10, 10 plus 8 18, 18 plus 1 19, 19 plus 6 25, 25 plus 9 34, 34 39, 39 and 6 45. So the sum that we have is 45. It is divisible. It is divisible. So when number is divisible by 9, it has to be divisible by 3, but the reverse is not true. The remainder in both these cases is 0. So another inference that we can see here is that you can eliminate of the 9s. So we can eliminate when we are dividing by 9, sorry, or even by 3, we can eliminate 9s. Whenever the sum exceeds or comes out to be 9, we can just drop it because 9 is obviously divisible by 9 and 3 as well. So just an example here, I see 8 and 1 is 9. I can simply drop it off. 9, I can drop it off. Then we have a 3 and a 6. I can drop it off. A 4 and a 5. I can just drop it off. A 3 and a 6. I can just drop it off. So the remainder is 0 because I've dropped all the 9s here. So my sum would come out to be 0 because I've just whenever I got a 9, I dropped it off. So that's kind of inference and kind of making the calculation easy for yourself. We can just eliminate the 9s. So in this question, let me check in this question if it is applicable. 8 plus 2, 10. 10. 10 minus 9, it's 1. So I have the sum 1 here. 1 plus 2, 3. 3 plus 4, 7. 7, 8. 8, 7 is 15. 15. So again, it's more than 9. I'll drop a 9. 15 minus 9, it's 6. 6 plus 5, 11. 11. Again, I'll drop a 9. So I get 2. 2 plus 5 is 7. 7 plus 5 is 12. 12. So I dropped a 9. My remainder is 3. I got the remainder in the very first position. I didn't have to come to 39. I got 3 directly. So that's the process. That's how you can do the same calculation in an efficient manner by eliminating the 9s. So that's about the divisibility rule for 3 and 9 as well. I'd be coming up with one more lecture on 2, 5 and 3 divisibility, wherein that would be logical outflow of the divisibility rules. That would help you understand how we have arrived to this divisibility rule per se. So thank you for watching. Stay tuned, stay safe, keep studying. I'm the professor. Bye bye.